Hey, what's going on, guys? CodeMikeGains here. In this video we're going to be implementing AddMove function that would be serving the purpose of populating the move list generated by the move generator. So the very first thing to consider, we need to define the structure storing our moves. So let me just go below my board definition here, and so where is this? Yeah, probably right over in here. I just want to define the MoveList structure, and this is going to be a little bit new stuff regarding the C programming language that we didn't yet encounter within this tutorial. At least if you're familiar with the C structures, it's great. If not, I'll try to explain them in easy words. I'll try to do my best in explaining this stuff. So we can use the structure, but even better practice, well, at least in my own experience, is to use what is known as type def structure. So we can define the new data type in C programming language, believe it or not. So if I say just type def and then this structure, and let's the name for this new data types would be moves. So we have like integer, we have float, we have character. So all these are data types in C, because like C programming language is statically typed, like Python is dynamically typed and C statically typed. So we need explicitly to specify what kind of data are we about to define. So here we will have an ability to define the data type of moves, believe it or not. So this is why this type def structure is needed. So it would allow us to define a new data type. And now you'll understand why exactly we need doing this. So it would contain the move list itself. So I can create the integer moves. So this would be the array, and as far as I want to keep things simple, well, in this series I don't really want to have this moves being appended dynamically. So I'm not going to be using linked lists here, which is a general practice for dynamic appending to the data structure, but instead I will create the the array of integers with a length of 256 elements, which is just a big number to make sure that there won't be more than 256 moves being generated in a row. So this is just literally enough. And the second variable to define here would be the move count. So move count, and I just defined the integer count variable like this. One little thing, in C programming language, unfortunately, well, maybe in the new version this is possible, but in the version that I'm using now, we can initialize the variables within this type def structure, like we do like we can do something similar in the high-level programming languages. So here we can do that, and we will need to do this later on when we create the instance of this sort of a structure. So it's not really object-oriented programming, but see, it doesn't support that. But this is something really kind of similar to that at some point. So this is it, and now I just want to go to the very end of my of the definition of my my functions, and here I want to define AddMove to the move list, or we can even say into, well, we can say push move into the move list like this. And let's create the void function AddMove here, and it would take a couple of parameters. So the first parameter, so remember we call that data type moves. Let me just show you this again because it's really essential to understand. So we just defined the new data type called moves. So this means that we can now use this data type to reference the particular data that would be taken as an argument within this AddMove function. So we can say like moves pointer and call the variable MoveList. So it's not the variable itself, but the memory address pointing at the location of the currently created MoveList structure. So MoveList and also int move, and this is just the integer that we would be using in order to initialize the current given move within our move list. And now the first thing to consider, we want to actually store, well, let's call this push move. I guess this is better to say like push move into move list right over in here, and here instead call this, well, populate move list. Okay, so push move into the move list, and now in order to reference this sort of a structure, remember it has two elements. It has the moves array and the which is the type of integer. Well, basically that's to be honest, that's not the integer exactly. It's more like a pointer to integer, because arrays are, okay, just forget that. That's the low-level programming theory. It's not the place for it here. Maybe one day I will create some tutorials on C programming, low-level stuff separately. So let me just show you how to apply this step. So if we say kind of move list, and now to reference the child element of a structure, we need to use this sort of a syntax. So dash followed by the greater sign, and then we reference our moves, which is an array, and we need to specify the index to index this array, and we use our move list in the move list and count that is available. There is another field within the moves structure, and this would be equal to a move itself, which is integer. So let's walk through this again, because this is absolutely essential. So we're taking the move list pointer being passed to our AddMove function. We're referencing the moves array within this move list structure, and in order to index this array, again we're referencing the move list element and its inner count field. Its inner field called count. So that's if the move list count equals to 0, which would be initialized, it would be initialized to 0 initially. Then it means that the moves within the move list indexed by 0 would be equal to move. And the next thing to consider, we need to increment move count. So we can simply say like move list and count plus plus, and that's it. Now we'll try to actually test this. So without further ado, let me just try to open my terminal in the current working directory. So here, in order to compile and run the stuff, I just type make to compile the source code, and if it compiles, I just want to run my chess hexadecimal 88 executable that would be produced just right in the moment. Okay, perfect. So we don't need all this stuff really anymore, and I just want to, well, we already have our move being generated, which is quite pretty nice basically, but I don't really want to print anything here. So okay, hold on a second, I just got a phone call. Okay guys, sorry, just been slightly bit distracted. So now in order to make use of our AddMove function, first we actually need to create our move list instance. So if I say moves, and this is like if I set int, okay, so if I say it like int and then like variable name, right? And here I just say like moves and the variable name. So this is the data type, just to make it clear what this move stands for. And the name for the variable would be the move list, and I want to create the only element for this. And as far as this is a list, we can just directly send this variable name into our AddMove function, and this already would be treated as the moves pointer. Well, it's a little bit too long to explain why exactly this is happening. You need to understand it. Arrays and pointers in C programming language. Once I did even a tutorial on my original called Geekins channel regarding this topic, but nobody really cared about that for some reason. Well, maybe I will make another one day. And another important thing to consider in order to avoid some segmentation faults or another C programming language related disasters, we also need to initially update our not to update, but initialize our count variable. So we need to say MoveList and reference the count variable, and this should be equal to 0. So this means that initially this MoveList moves array would be indexed by 0. Otherwise it would be referenced by some random undefined value, and this ends up with a segmentation fault or a disaster like that. And from now on we can actually call our AddMove function. Okay, and we need to pass our MoveList as the first argument, so pointer to our MoveList instance here, followed by the move. So followed by the move like this, and it won't print anything to screen now, but I just want to compile and run to make sure it works. And let's actually create another move here. So just copy, paste, and let's say E7, E5. So I don't want to encode any pieces really. I don't need any flags. Just the bare from and to square quiet moves. Okay, so I did add move. So this would be move 1, this would be move 2, so move 1. Also I want to manually add this move 2. So hope it compiles and runs. What? Move 2. What's wrong here? Move 1 isn't declared. Oh my god, what have I done? So yeah, let's say like this, int move 1 would be equal to, oh, this might not work as well because we don't have the move being initialized. Or is this gonna work? I'm just wondering. Yeah, it seems like. So okay, yeah, it should have. So I'm just calculating this within my brain. I'm sorry guys. Okay, this is yeah, one day you will definitely understand this process, and you would be doing literally the same if you were about to keep on chess programming ever. Okay, so I'm just wondering, like, now we need to loop over the move list. So, well, let me just provide some more commentaries, even though this code would be deleted in the further videos, but within this part it would stay forever basically. So here we just create move list, well, let's say instance. It's not really best way to say move list. Okay, let's say move list variable. Okay, let's just call this move list variable. So here we initialize move count, and here we just add moves. So this is quite pretty self-explanatory, I hope. And now let's loop over moves in a move list. So what I want to do now, I can say for int index equals to 0, index less than, so we have well, actually, so before I do this, I just want to print the value printf of our move count. It should be equal to 2 because we have this 2 values within our move list, and then we'll be using this as the range of indexes. So decimal format and new line, and I want to print move list and the count. Okay, it should be equal to 2. Yeah, perfect. So this means that I can actually now use this move list count in order to specify the index range, right? So index won't be ever more than the move list count, and finally index plus plus. And now we want to reference well, let's create this another move variable int move would be equal to, and now we reference our move list, and within the move list we're referencing our moves array, and within this moves array we're referencing the index. Okay, and we just now print our move. It should be printed. I'm not gonna be printing I'm not gonna be decoding this move, just as a proof of concept. Just want to make sure that the moves are actually sorted there. So we would see a couple of integers that won't really tell us much because of being encoded, but still I think, well, this is literally enough to test this AddMove function here. Okay, so, and I just want to print the move, and I hold my breath, print f, and let's run this stuff. Okay, so we got 2 moves being added to the move list. So you see, like, the move list array, the moves array within the move list structure looks like the array of integers, and these integers do represent the from the square and the to square, like those squares we're kind of talking about. And well, okay, let me even show you this. Let me show you even more. So let's consider this moves, and I can say get move source and the move, and we want to say square to index. Okay, and also just to give a normal human readable representation, and get move target. So we're not going to be referencing the fancy flags, but just okay, square to index. Oh, sorry, square to coordinates. What I done? Square to coordinates, and the square to coordinates. That's the exact name of the array to convert encoded square indexes to human readable coordinates like A2, E4, and so on. So we got these 2 moves being stored within the move list, so E2, E4, and E7, E5. So these 2 moves, just these 2 moves, these 2 guys has been added. Probably we don't really even need to. We can do it like this. Okay. Paste. Yeah, I think this is literally enough. Basically, save. So the result should be the same now. Okay, perfect. And from now on, we can actually already embed our move list, move population within the move generator, and this is quite pretty important topic. So probably, I don't know, yeah, probably I will just end this video at this point. So we just didn't implement our AddMove function, and the next video, because it's really important, and I want to emphasize that in a separate video to make sure that you watch that and understand like what's going on there. So the next video we're gonna be embedding this AddMove function into Move Generator. So that's kind of it. Well guys, so I hope you've enjoyed watching this tutorial and learned something interesting out of it. Thanks for watching. Until the next time, and take care.